Okay, now there was a comment earlier about what happens if you turn your mobile off and you want to restore your connection later. So these problems have had to do with fading. So if there's a fade that's very brief in time, you want to be able to recover from that very quickly without having to go through slow start. So there's an alternative problem, a different problem. Than fading, which is what happens if you have a brief disconnection. Wireless device. And this can happen in wireless data networks in the following scenario. So it's less likely to happen if you actually turn your device off and then turn it back on. It's more likely to happen in the following kind of scenario. Here's figure 4. So if you're in a building, let's say that here's 2 rooms in a building connected by a hallway. So there's your hallway. Actually, it's not where the doors there. So there's a wireless network in one room, wireless network in the other room. You start with your mobile here, walk over here, except the wireless network is not present in the hallway. Or maybe a hallway is unrealistic here, maybe in the elevator. You step into the elevator and you briefly lose your connection. So each of these has a valid access point. And your objective is, so you have your mobile node here, you start downloading your DVD of Ubuntu or whatever, and then you walk in that, which is going to take. So the reason why I'm using such an example is I can't think of anything else that's fairly large that you wouldn't be able to download within the second it takes you to walk from here to the door. So you start downloading here, enter the hallway, signal weakens and weakens and weakens, eventually it disconnects, and there's a brief period while you're in the hallway here that you'll be between the 2 networks, and eventually you'll reconnect over here. So the question is, how do you maintain your TCP connection while you're sort of between networks? So the protocol here is called mobile TCP. And I should mention, so when we were talking about mobile IP is actually a widely accepted protocol that's part of the IP set of protocols. Mobile TCP does not have that status. It's not formally accepted throughout the internet, and it's not like the mobile version of TCP. It's solely set up to solve this particular problem. The idea here is to keep TCP connections alive during short disconnections. So the problem that we're not solving here is the fading problem. This mobile TCP does not solve packet losses due to fading. In fact, we assume the signal strength is always good. Yes.
How do we assume that if the signal strength goes up?
So the method that I'm about to describe here is, oh, I see what you're saying. So it's more of a consistency issue. So as long as you're connected, the signal strength is assumed to be good, and if you disconnect, then the signal strength is assumed to be bad. Excuse me, is only assumed to be bad while you're disconnected. So in the other two problems, we were talking about transient packet losses. So in other words, you very abruptly enter a deep fade, and it's very abruptly over, so you only lose a packet or two. Here, we're walking from one place to another, so you could lose the connection for a significant period of time, several packets. Yeah.
So you need to use this with one of the other, like adjustments we just discussed?
Yes, in fact, this is independent. The solution here is actually independent of the others.
So is this a modification of the actual TCP protocol?
Yes.
Oh, okay.
So once again, end-to-end connections are maintained. And what will happen is the access point will monitor the TCP connection. So much like snooping TCP, in fact, you could probably implement mobile TCP and snooping TCP in the same system because they're kind of orthogonal to each other. So the access point monitors the TCP connection, and if several acknowledgement packets are missed, then the AP will assume the mobile has disconnected. So the job of the access point here is to keep everything alive, to keep the connection alive. So if the disconnect takes a significant amount of time to resolve, the risk is that too many packets will be dropped in order to recover connection. In other words, if the source just keeps transmitting packets, every packet in the disconnection will be dropped and will have to eventually be retransmitted. So the access point has to have a way to tell the corresponding node to stop sending packets. So it turns out there's a trick you can use in TCP. So the access point sends a control message to the corresponding node, in which it so it turns out endpoints of the TCP connection can tell each other what window size to set. So we remember the significance of the window size. So the window size is basically the number of TCP packets you can transmit without acknowledgement. Yes.
So